Hello, what's up, guys? My name is Prabhat Singh. So today, I go with the very famous LeetCode problem, two sum. But I want to discuss another problem, but it's relatable. So I go first the two sum, and then I proceed in my next video with three sum because I want to discuss three sum, but uh, but there is a little bit concept of two sum there. Little bit no, almost 90% concept of two sum. Just a little bit change, and the three sum is done. So let me share my screen and go with two sum. And look at this problem very uh, carefully because I discussed three techniques. First one is brute force as always because we have to think always brute force first. uh, it's not a chanting, not a sorry, but a uh, not a priority that brute force. But if you think first brute force, then it's very obvious way to then optimize. So it's very clearly to visualize the problem. Very clear way to visualize the problem. So let's go with uh, actually I have an habit to explain more and more. That's right. So it's a very obvious after reading. So we can read problem, but uh, after reading what we got from here, suppose in an array there is a target 9. So we have to find the two number which sum is equals to target. So let's see with the example. So here 2 and 7. So firstly we got 2 and 7. So we got our answer as 9. Yeah, we are done. And one more thing, what, yeah, this line, you may not use same element twice. So if you have, let's suppose our target is 9. Let's suppose 10. So take it even number. Mm, just to one second to clear my, sorry, clear now. Yeah, clear. Let's come to, suppose we have 10. So we can't use 5. Uh, Suppose 5 at the indices of 0. So we can't use the same indices. It's that simple. So we can't use 0, 0 twice. So I think you understand the problem. Let's go. Uh, okay. So let's clear here. So let's think in a way of we have a array of 2, 7, 11, and what 15, I guess. Whatever, because the target is 9. So anything, anyway, the number is anything, we don't care. So what's my first approach? I take a loop. So don't think about loop. Just take as a symbol. So I pick one element 2 and I always compare with 7, 11, and 15. If I got a sum 7 plus 2, which is 9, then I suddenly then I don't go further and break my whole thing. Who I am saying always no, because I always think to the code, but I have to just visualize first here. So then I break, and yeah, it's our brute force approach. Every time I pick one element and always compare with others. Pick one element, compare with others. If you got some, it's very true. We have to break no further because if you get our answer, so why we need to go further? So yeah, it's a simple brute force approach. It's a very lengthy process to clear frame. Okay. So now let's uh, come with another approach. So our array is 2, 7, 11, 15. So why I'm not using a sorting algorithm here to because approach 1 time complexity and square. So now I have to decrease my time complexity. So let's think how. So what I do, I just copy this array and then I sorting tags. So it's already sorted. So no, there is not a worry thing because I already get a sorted array. We got a situation where we don't get sorted array. So to minimize that thing, so now let's see how we can use this technique. So what's my technique? What's my approach now? I take a left pointer and I take a right pointer. So here my right, left. So I just simply sum these two values. If sum is greater than target, I just if sum is greater than I write minus minus. Sorry, I don't have a space. And if sum is less than target, so left plus plus. So because it's obvious now, if you got less sum, so increase your value because it's sorted array. That's why it's a two-pointer approach. If you got some target, then simply break and push the left and right. And now I tell you why I'm not using that array. I just told you that copy that array and use deep clone, not shallow copy. So it's not take the reference of the memory of our original array. So now I compare that left and right with the original array and took out the indices because our approach is our output is indices. So that's why. So it's also good way. So our first approach have n square, second have n log n because sorting. Now it's good. It's good. We are optimizing. But I have a one more technique. I told you three techniques I have. So now I give you a technique which have O of n. So let's see how it's O of n. So we have a array 2, 5, 7, 2, 7, 11. That was 15. And target, sorry, my handwriting is not so good because I always type, that's why. So yeah, so what's my approach? So you might heard about a technique if you want to uh, if you want to decrease your time complexity, your space complexity will increase. So space time. So we have to follow this approach, not that previous one. Time. So everyone needs time. Everyone has not enough time. So everyone wants their time complexity always decreases. So let's proceed with this way. So for space, if you want to use object, but I highly recommend use hash map because if you don't know hash map, then I go with the object approach. You proceed with the object approach, but I highly recommend use hash map because hash map is very useful. So what I did here, I just put everything in a hash map and set a value, the nums of 5 with their indices. So 7 have 1, 11 have 2, 15, 0, 1, 2, 3, 3. Now, what I do here, let's remove everything. Yeah. So now what's my approach here? So every time I just put a take, I just use a formula. So you know now, two number a plus b, we got target. So why not go with this? Target minus b is equals to a. So if you find a in hash map, sorry, in hash map, then we simply return now. Then we simply break the loop and put that I and the hash map one I. So hash dot get whatever this value. I just go with the pseudo code, not I do code in JS, but let it be approached way to code first. Every time I just compare that variable, whatever I got here. So put here A. So every time we compare A is there or not? But one more condition, and then what the condition is? I just check that I is not is equals to that indices, because if I got I and I, so we have to restrict that point now. So I think we got a clear overview of pseudocode, because so let me go, don't go in hurry. So this condition, you may not use same element twice. So we have to consider this in our code also. How we prevent this? How we prevent from this situation? So this I never gets is equals to with this indices. So let try run. So I just created a hash map. This is my hash map. I know that hash map is not look like this, but anyway, just consider this. So I pick two. Okay, and my target is 9. 9 minus 2, I got 7. Then I compare is 7 is there or not. So I found yes, 7 is there. And one more condition. My I is now 0. So my 0 is equals to 1. No. So this condition also got passed. So now I got my I and that value 1. So this is my answer. So I know it's a little bit tricky, but let's code me, then you got everything. And for PC, it's O of n and space O of n has moved there. That's it. So let's code it. Hmm. Hmm. Let has equals to map equals to 0. I is less than non-store length I plus plus. So my initial I show you the output also has dot set. So it's a hash map has three things: set, get, has. Now you have to remember just these things. Nums dot length. Oh, sorry. Why I'm using nums dot length? Oh, and what I. So let me console you and show you how our hash map now looks like. Console.log has. So it's a typical that I show you previously. 207112. Yeah. So now for let I is equals to 0, I is less than stop and I plus. Now take this. Let current is equals to target minus terms of I. Yeah. So if has dot has target and norms of, and why I'm using has, because sorry, not target, my mistake. Why I'm using has, because if it is present or not, first let's check this. And one more condition, if has dot get. So how I can get this indices? So the get method curve is not as equals to uh what nums of I no sorry it's not is equals to I, so we prevent from that repetition element. uh hmm, let me set a result uh, push I am has 4 and return result. Yeah, we are done. Hmm? Why? Hmm, check this. Why I'm getting wrong? Hmm. Oh, oh. Okay. Hmm? Oh. I have to break also. Yeah, now I will. Because why I have to go further now if I done with my answer. Yeah. So we got our answer. Oh, cool. It's a very 97%. It's a good time complexity, I say. 67 just runtime. So cool. It's a cool time complexity. So basically, we have to do like this. So I told you now, this approach will be further uh, used in threesome. So let's do this problem in my next video because it's already lengthy. So I don't got you to be in a what in a hard situation to solve numericals. So if you like this video, please like, share, subscribe, share it everywhere. So stop this screen. Yeah. So for now, it's done. So if you like this video, please comment below that you like. So I have to know. Yeah. And also you have to do any JS problem, advanced React. So let me comment below. I'll just go and look through that problem and make you the simple approach to think. So for now, bye bye. Till then, take care. And in my next video, I will go with threesome. I might sure that approach should be little bit different, but this is a series: two-sum, three-sum, four-sum, and if there is a problem, five-sum, we will also handle this. So till then, bye bye. Take care. Bye.